Okay, let me tell you about one of the greatest, most foundational stories in the history of science. You have a massive battle between two ancient empires, it's been raging for years, and then, suddenly, it just stops, dead in its tracks. And not because of some treaty or a clever general, but because the sky itself just went dark in the middle of the day. But here's the kicker. One man, a philosopher named Thales, supposedly saw it coming. This is the story of that eclipse, an event that might just be the very birth of science itself.
The ancient historian Herodotus, he's the one who sets the scene for us. He tells us that for 6 long years, the Lydians and the Medes were just locked in this absolutely brutal war. Then, right in the middle of a huge battle, the unthinkable happens. I mean, just imagine the sheer terror. You're a soldier, and the sun, this symbol of divine power, it just vanishes. The soldiers, they're completely convinced it's a terrible omen, so they drop their weapons. They were so shaken that they sued for peace right then and there.
And this is where the story shifts from being just history to becoming a full-blown legend, because Herodotus claims that Thales of Miletus, an Ionian philosopher, had actually warned his people that this loss of daylight was going to happen that very year. But how? I mean, this was a time when an event like that was seen as pure divine intervention. So how could a mortal man, centuries before we even had telescopes, predict it? Was this some incredible stroke of genius, or was it just a really, really lucky guess?
To even begin to figure this out, we have to start with the event itself. And look, this isn't just some fun historical anecdote. For a lot of people, the prediction of this eclipse marks the moment humanity started to realize that the universe wasn't just chaotic and divine, but that it was orderly, and most importantly, that it was predictable. It's like the symbolic starting line for rational thought.
Okay, so here's where modern astronomy gives this legend a really solid foundation. NASA calculations, they confirm it. A total solar eclipse did happen on May 28, 585 BCE. And its path of totality, it sliced right across ancient Anatolia, what we now call Turkey, which is exactly where the Lydians and Medes would have been fighting. So the astronomical event, that's real. The big question is, was the prediction?
So, let's dive into the first big theory. Maybe Thales didn't have some secret, super advanced mathematical formula. Maybe he was just an incredibly patient and sharp-eyed observer who happened to have access to some pretty decent records.
This idea, which is championed by researchers like Dirk Couprie and Leo Dubal, is basically that Thales's genius wasn't in complex physics, but in something much simpler: pattern recognition. He would have been looking at lists of past eclipses that were visible from his home city of Miletus, just searching for a rhythm, a hidden beat in the celestial drum.
And this chart here, it shows what he might have seen. If you track the eclipses visible from Miletus in the decades right before 585 BCE, this really fascinating pattern starts to emerge. They seem to come in these little clusters of 3. If you look closely, you see an eclipse, then another one 17 or 18 lunar months later, and then a third that completes this 35 lunation cycle. That's 35 full moons for the whole cluster, and then after that, a long, quiet gap before the next cluster starts up.
So the method they're proposing is, it's beautifully simple. First, you just record every solar eclipse you can see. Second, you spot these 35 lunation clusters. And third, once you see the first 2 eclipses of a new cluster, you just project forward 17 or 18 months to predict the third one. And it just so happens that the eclipse of 585 BCE was the third in exactly such a cluster. It seems plausible, right? Almost elegant.
But, like with any good mystery, just when we think we have a neat answer, a new piece of evidence shows up and just complicates everything. It turns out this simple, elegant pattern has a major, major flaw. Okay, so here is the crucial flaw, according to research by Miguel Querejeta. That neat little pattern of clusters, it only shows up if you selectively ignore some of the data. The whole theory assumes Thales only recorded eclipses of a certain brightness, a certain magnitude, but what if he recorded everything he could possibly see?
Just look at this. On the left, you've got that selective list of eclipses that creates the neat little pattern. But on the right is a much more complete list of what Thales could have actually seen, including dimmer eclipses, or ones that happen near sunset. And as soon as you add in events from, say, 633 BCE or 603 BCE, that beautiful 17, 18, 35 lunation pattern it completely disappears. It turns into a chaotic jumble of dates with no obvious rhythm at all.
And this really highlights the huge practical problems for any ancient astronomer. The whole idea of a perfect, unbroken record of eclipses is really a modern fantasy. What magnitude does it have to be to count as observable? And more importantly, what happens on a cloudy day?
An eclipse could be total, but if it's overcast, nobody sees it, and it never gets written down. The data Thales actually had to work with would have been patchy and unreliable at best.
Okay, but let's give him the benefit of the doubt. Let's just say Thales did have perfect records. Even then, he would have faced another absolutely massive hurdle, statistics, because predicting solar eclipses from one spot on Earth is just really, really hard.
And this really gets at a key difference between lunar and solar eclipses. See, lunar eclipses are visible from basically half the Earth at once. So cycles like the Eclipse are great predictors. They have over 76% success rate. But a solar eclipse is only visible along a very, very narrow path. So trying to use that same cycle to predict a solar eclipse from one specific city like Miletus, it's a much worse bet. The success rate just plummets.
And if Thales had tried to use the even more famous Saros cycle, that's a period of 223 lunations, his odds were, well, they were even worse. The chance of that cycle correctly predicting a solar eclipse of any significant size over Miletus was a minuscule 6.9%. Seriously, you have a better chance of hitting your number on a roulette wheel.
So this leads to a pretty stark conclusion from the research. Given the unreliable data and just the terrible statistical odds, even if Thales was using some kind of cycle, his success really wasn't science. It was, in all likelihood, an incredibly fortunate guess that just happened to come true in the most dramatic way you can imagine. But the problems don't even stop with the astronomy. The history itself is frankly a mess. We've been so focused on whether the prediction was even possible that we've kind of overlooked an even more basic question. Did the battle and the eclipse even happen at the same time?
So here's the kicker. While modern astronomy can pinpoint the eclipse to May 28, 585 BCE, ancient history is nowhere near that precise. As historian Nikos Kokonos points out, trying to fix absolute dates in the Greek Archaic period is notoriously difficult. The date of the Battle of the Halys River isn't fixed at all. It's actually tied to the fall of the Lydian capital, Sardis.
And this timeline just shows you the problem so clearly. I mean, depending on which ancient chronographer you decide to trust, the fall of Sardis could have happened anywhere across a 10-year span. Eusebius places it in 548 BCE, but the Parian chronographer puts it way down in 542 or 541 BCE. There's just no consensus. The historical timeline is shaky, to say the least.
And the root of all this confusion? It comes from ancient historians using two completely different lists of Lydian kings. Herodotus's list says the dynasty lasted 170 years, but another, non-Herodotean list, which you find in later sources like Eusebius, gives a shorter length of 153 years. And depending on which list you use, you get a different date for the fall of Sardis, and because of that, a different date for the battle the eclipse supposedly stopped.
So let's just recap the case against this whole legend. Thales would have been working with incomplete eclipse data, thanks to the whole what counts as visible problem and, the simple fact of cloudy days. Even with perfect data, the cycles he could have used had terrible predictive odds for solar eclipses. And finally, the historical event itself is on this floating timeline that might not even line up with the 585 BCE eclipse at all. The hurdles are just immense.
So, in the end, the evidence really does strongly suggest that the story of Thales' prediction is more legend than fact. Probably a lucky guess, or maybe a story that was told years after the fact, connecting two dramatic but totally unrelated events, a famous eclipse and a famous battle. But here's a final thought. Does it really matter? Maybe the story's real power isn't whether it was historically accurate, but in what it represents. This enduring, inspiring idea that the universe is not just a stage for the gods, but a puzzle that we, through reason and observation, can actually begin to solve.